Hello everyone. So I've been pondering a while now a kind of a GAV version of a near eye unit, and there are people out there who's made them, and they've done quite well. I had my own little bash using an angel eye and a 3.5 inch viewfinder, but it sits on the side, it's a bit clunky and so on. But what I want to do is kind of just go through some of the theory that I'm having to work through at the moment, and some of the old guard will quite happily think that this is nothing new and it's been out there for ages. However, for those who are wanting to look at potentially having a bash themselves, I think it's quite nice to share the thoughts that I'm going through to obviously see whether we're all on the same track. But we'll work through. So, as you can see, the different formats. So this is me sharing screen. So this is a program called Tinkercad, and I quite happily encourage anyone to have a go out there if you want to get into doing some 3D type designs, because it helps visualize certain objects, and you can actually put dimensions in there to give it a bit of substance to what you're wanting to do. So let's move on. So what we've got here is I've kind of used a blue ball as a representation, as literally the your eye essentially, and the yellow parts here give you an element of understanding as the eye relief, and the orange part here represents the scope. So as you can see, as which we all know, obviously there's a distance between where your eye goes, the eye bell, and that's called your eye relief, and that's where you get your optimal picture. So which is great. So in the normal run of things with a standard eyepiece, standard night vision add-on, what you then get is you're representing the blue ball, which becomes your camera. So a camera module, a bit like this. What you're then doing is simulating almost its positioning of that camera to represent the eye relief up against the scope. Easy done. So this is something that we've a lot of us on the Night Vision Builders group has been doing for a while now. Now the element of then actually bringing it into a near eye unit, which would be very much is that you're kind of then wanting to represent here on the screen where the camera, sorry, not the camera, the screen would go. That's what we're kind of referencing to, is that essentially you're almost wanting to look as if you're looking through the scope to be your image, and it presents a lot of difficulties. Now I did a unit way back which basically had 3.5 inch screen slapped on the back and it pushed up front. Now it did work, and can work if you want to use that, but it had its own obstacles. One of them, which was very much it was really close to your eye, which again was okay or not, but in terms of the strain on your eye, it was functional, but it didn't do the trick. So to get over that, we've got to then start being a bit creative and utilising essentially almost a prism to try and get the distance of the eye relief to be still the same length, but shorter up as close as we can to the scope itself. So on the screen here, then you get something like this. So, oops, if I move around. So if we say that now we've got two prisms represented by the green triangles, we've now got where the camera would sit, a flow through where it hits. So the distance is the same going through, but as you can see here, it's a lot shorter. So this red block here represents a screen type. So I'm looking at something like a 1.2 inch screen, so a very tiny screen. I've got to do a bit of shopping around for that and see how I can pull that together. But then obviously that then enables the view to go out, and your eye would represent as this. So you can see there where the eye relief is generally staying the same, but we're then moving a screen, instead of being over here somewhere as if it was beforehand when I did it, it's actually a lot closer. Now we can actually modify this a little bit more by moving the prisms closer. So what I've done here, as I've done something like that, oops, and as you can see my camera now is reaching over the scope and then bounced all the way through. Again, the distance is all the same, but what we've got now is a difference. Oops, if I as you can see, the prism is now a lot closer. These are also known as individual Austin informed me is a beam splitter. It's the first time I've heard them be used as that, but I've known this as a prism, but the other term could be beam splitter. So as you can see, I've now managed to move the screen even closer, which gives me an ability to have still an eye relief further back, and this is where the image will then come out. Now I think this will be a lot better personally, but it also has its own challenges. So in terms of putting this over the scope itself, on my scopes at least, I've got a that allows me to put the illuminated reticle on. Anyway, so that gets switched on and off. So obviously at the moment, if I was to have this upright, this would cause me a bit of problems. But what I can do is I can easily alter this, and I can have it a kind of a side mounted, because ultimately it's not going to matter which way up I put this in terms of the way the camera sits. As long as I rotate the camera to compensate, the image will stay the same. So that's what we've got. Hopefully this will work. The other obstacle I've got here is this screen. I think will need some form of at least magnification. So for example, the viewfinder that I've got currently using, the Angel Eye, that's got an element of magnification on there, and I want to build something in there as well as that, and I think that'll actually come out as quite a bit of a neat kit. Downside at the moment is parts are en route from China, so it's going to be at least 4 to 6 weeks, but in the meantime I can at least start tinkering around with some kind of initial prototype designs on how this is going to fit in. Now one of the other obstacles I'm going to run into is I've got to make sure that the prisms are put in and they're in square, and also that they're not actually adrift left or right, because in terms of alignment we need to be pretty much straight on with this. So that's where we are at the moment. So yeah, might turn out well.